children, welcome to maths classes. Children, today let's discuss problems of exercise 1.2 in the chapter number systems of class 9 NCERT maths textbook. Children, what is the first problem? State whether the following statements are true or false and justify your answers. Okay children, you should state whether these statements are true or false. What is the first statement children? Every irrational number is a real number. What they are asking? Every irrational number is a real number. Is this true or false children? Is this statement true or false? What do you know about real numbers children? Real number is nothing but, real numbers are nothing but rational and irrational numbers. All rational and irrational numbers together they are called as real numbers. Rational numbers also include natural numbers, whole numbers, integers and numbers in the form of fractions, that is numbers in the form of p by q. And irrational numbers means you know those numbers which are not in the form of p by q. Here numbers which are in the form of p by q. Natural numbers 2 can also be written as 2 by 1. 0 can be written as 0 by 1. So all natural numbers, whole numbers, integers they come under rational numbers, and irrational numbers are the numbers which are not in the form of p by q. So all these numbers together are called as real numbers. So all the numbers on the number line, rational and irrational numbers, you can call them as real numbers. So here it is said that every irrational number is a real number. So according to this statement children, rational and irrational numbers together they are called as real numbers. So every irrational number is a real number. This statement is true. So this statement is true children. How can you justify this statement? We can justify this statement by telling that real numbers are a combination of rational numbers and irrational numbers. So the statement every irrational number is a real number is true. Let's solve second question children. Every point on the number line is of the form root m, where m is a natural number. What is the statement children? What they are telling? Every point on the number line, each and every point on the number line they are telling it is in the form of root m. What is m here? M is a natural number. Let's see children. They are telling every point on the number line. So let us assume the number line and consider some points on the number line. 0, 1, 2, 3, 4, minus 1, minus 2 and so on, and some numbers 0.5, 0.3, 0.3 is in the sense 3 by 10. This is 5 by 10 or 1 by 2. Let's see children. They are telling every point on the number line is a form root m. Let's consider one number 2. Is this number of the form root m children? Let's see. 2 can be written as root of 4. You all know children, root 4 is 2. So the number 2 can be written as root 4. 4 is natural number here. So 4 is natural number here. If we consider the example 2, this statement is true or false? Every point on the number line is of the form root m. 2 is on the form root 4. That means 4 is natural number here. That means this statement holds true here. If example 1, first example if we consider the number we took is 2. In this 2 can be expressed as root 4. So it is, we are able to express it in the form of root m. That is m is a natural number. N means natural numbers children. Natural numbers are notated by n. So for example, by considering 2 as an example, this statement is true. Let's consider another example. Let's consider 4, number 4. 4 can be written as root 16. Here 16 is natural number. So the statement here also, this statement becomes true. Now let's consider another number children. Let's consider one decimal number. 0.5. How will you write 0.5 children? If you want to write 0.5 in the form of square root of another number, how do you write? You all know children, 0.5 can be written as root of 0.25. Is this correct or wrong children? Let's see. How do you write 0.25? 0.25 can be written as 25 into 10 power minus 2. Root is there. Root 25 is 5. Root of 10 power minus 2. 10 power minus 2. If it comes outside of root, it will become 10 power minus 1. You got 0.5. So, see children, 0.5 can be expressed as root of 0.25. Check whether I wrote this as correct or not. 0.25, how can you write it? After decimal point, you have two numbers, two digits you have after decimal point. That means you can write 25 into 10 power minus 2. Root 25, you know it as 5. 10 power minus 2. Square root of 10 power minus 3 is 10 power minus 1. 5 into 10 power minus 1 is nothing but 0.5. So 0.5, we are able to express it as square root of 0.25. Tell me children, 0.25 is 0.25 natural number children? No, 0.25 is not a natural number. But in the question they are telling every point on the number line is of the form root m, where m is natural number. They are telling m is natural number here. Children, observe this carefully. Natural numbers start with 1, 2, 3 and so on. They cannot be in the form of decimal number. They cannot be in the form of fraction. Natural numbers cannot be in the form of fraction, children. Now you got what? Root of 0.25. You got decimal number. This is not natural number. So this statement becomes false in this case. So children, did you understand? We consider 2, 4. In these two cases, 2 we are able to write as root 4. 4 is a natural number here. 4 we are able to write as root 16. 16 is a natural number here. In these two examples, this statement became true. But let's consider another example, 0.5. 0.5 is also a number on the number line. They are telling every point on the number line. That means you can consider any point and we can check. We consider point 0.5. This is also there on the number line. We write 0.5 as square root of 0.25. 0.25, is it a natural number, children? No, 0.25 is not a natural number. It is a rational number. So, the answer here, they are telling m should be of the form of natural number. But here, root m is not a natural number here. So, the statement every point on the number line is of the form root m, where m is a natural number. This statement becomes false, children. So, you can justify this statement by giving this example. Let's consider the next question. Every real number is an irrational number. Just now you came to know that real numbers are nothing but a combination of rational numbers and irrational numbers. That means real numbers doesn't contain only irrational numbers. Real numbers also contain rational numbers. So, this statement every real number is an irrational number is false. Every irrational number is real number, children. Every irrational number is real number. But every real number is not an irrational number. Let's consider example 1, 2, 3, 0, 1 by 2. All these numbers are not irrational numbers, children. So the statement every real number is an irrational number is false. This is the problem 1 in exercise 1.2, children. Second question, children. Are the square roots of all positive integers irrational? Are the square roots of all positive integers irrational? If not, give an example of the square root of the number that is a rational number. So children, they are asking if square roots of all positive numbers irrational. So children, let's see, children. You all know what are, give some examples of irrational numbers, children. Irrational numbers are the numbers which cannot be expressed in the form of p by q. Irrational numbers cannot be expressed in the form of p by q, where q not equal to 0. You all know some examples of irrational numbers. Root 2, root 3, pi, root 5, root 7. All these, children. See, consider these examples and see the statement, children. Are the square roots of positive integers? 2 is a positive integer, 3 is a positive integer, 5 is a positive integer, 7 is a positive integer. In all these, root 2 is an irrational number. That means this statement is becoming true here. Root 2 is irrational. Root of positive number, root of 3, a positive integer, is irrational. So here also the statement is becoming true. Here also the statement is becoming true. Root of 5, 5 is a positive integer and root 5 is a irrational number. Root 7, 7 is a positive integer and root 7 is an irrational number. So can you tell that this statement is true, children? No children, let's see some other examples. What is root 16 children? Root 16 is 4. You all know that 16 is a positive integer. We consider positive integer and square root of positive integer. Square root of positive integer 16 you got as 4. Is 4 a rational number or irrational number children? 4 can be expressed as 4 by 1. That means you are able to express as P by Q. So, it is a rational number here. So, this statement becomes false. Here 4 is a rational number. Let's consider another example children. Root 9. 9 is a positive integer. 9 is a positive integer. Square root of positive integer. Square root of positive integer 9 is 3. 3 is, yes children, 3 is rational number. It can be expressed in the form of P by Q. 3 is a rational number. So this statement becomes false in this case also. Here children, root 16 and root 9. When we consider the positive integers 16 and 9 and we consider the square root of these numbers. Square root of 16 you got 4 and square root of 9 you got 3. These two are rational numbers children. But they are telling all positive integers, square root of all positive integers is irrational numbers. You got rational numbers here. So the statement is false. You can give this example children. Root 16, root 9, root 25. All these. Root 25 is 5. 5 is also rational number. So you can tell that this statement is false. Give these examples children.
Thank you for watching the video. Like, comment, share and subscribe.